the simulator, it's going to look like this. And what you can do for fun is just click Start Animation right here, and you'll see some arbitrary object zooming around the sun in an orbit. Okay, now we want to track and figure out what goes on with the planets because ancient peoples were able to observe the planets and measure things like the time it took them to go around the sun and how far they were from the sun. So in order for us to do that, I'm going to click pause animation. We're going to choose the planets here. So if you look at the drop down list here, um, all of the major planets plus Pluto are listed. I'm going to start with Mercury, and you've got to hit OK or it won't load the parameters for Mercury. Now, you are not going to mess with these. Those are specific for Mercury. What we are going to do, though, is use the semi-major axis here as an approximation for the radius of the orbit. Okay? So this number here, 0.387, is going to be our radius of our orbit. And so you're going to put that in your spreadsheet as the radius, and that's in a unit called the AU. And then in the notes, you can see how to convert AUs to meters, but we're going to record it, first of all, just in AU. What you can do is start the animation then, and you'll see that Mercury is zipping around the sun pretty fast. The animation speed is right here. It's 0.20 years for every second of real time. So what you are going to do is you're going to time how long it takes to go around. And once you know how long that is in seconds, then every second is equal to 0.2 years in orbital time. Okay, so this is going a little fast, so I'm going to just slow it down a little bit. I'm going to go like maybe here. And I want to time it for several laps, several revolutions, so I can get a very accurate measure of the orbital period. And it will help you if you click down here where it says Show Grid. So I might think about this point right here. 3, 2, 1, go. I start my stopwatch, and I'll time it for 1 orbit, 2 orbits, maybe I'll do 10 orbits or so, okay? You need to pick enough orbits, enough revolutions, so that your time is at least 20 seconds. Otherwise, you won't have very good accuracy on your lab. And then once it's revolved 20 times, you're going to stop your stopwatch, stop right there, and then you're going to record that in your spreadsheet. So for each of the planets, Mercury, Venus, Earth, Mars, and Jupiter and Saturn, for those first 6 planets, because those are the ones that can be observed with the naked eye. Those are the ones that the ancient peoples could see. For those 6 planets, you're going to record the semi-major axis, which is a proxy for our radius of our orbit, and you're going to measure the simulation time it takes to orbit. And then once you know the simulation rate and the number of seconds it took to orbit, you can figure out how long it takes to orbit in years, and then you can convert that to seconds. And then our job is to figure out how does the orbital period depend on the radius of the orbit. Okay, so just a couple things to show you here. If I go to something that's not quite so elliptical like Earth, here's Earth. You got to hit the OK button for it to switch. Here's Earth, and the sun is almost in the dead center. So the semi-minor axis is the distance from here to here, and the semi-major axis is the distance from here to here. And for a perfect circle, those are exactly equal. But for elliptical orbits, they're not quite equal. And so for the orbits of the planet, we're going to use the semi-major axis as basically our radius there, okay? All right, so that's what you need to do. As you get to bigger orbits, for example, when you get to Saturn, it's going to go really slowly. So you might want to up the animation rate, maybe up to, I don't know, something like let's do 2.5. So there. So there's 0.25 years for every second that happens with the animation. So now you can see every second that goes by on your watch is 2.5 years of real time. So even that's a little slow. Maybe we should go to 1. So every second that goes by is equivalent to 1 year. So you can time how long it takes to go around there. Okay? And we're just going to go to Saturn. You could do it for planets past Saturn, but those weren't observable to the peoples of ancient times, they're not observable with a naked eye, so we won't look at those either. All right, so that's how you run the animation and collect your data. Then you'll need to get a straight line. You can check your slope and let me know if you have any trouble.